Hi, this is Discrete, lesson 5.3, finding the shortest route. Now, if we look previously in 5.2, we did the traveling salesperson problem. That was where we started at one point and we finished at that same point. And then we found out that there was many different ways to calculate that, and then that was extremely difficult to do. So we learned the nearest neighbor, and we also talked about the cheapest link methods in order to get that done. In this section, it'll be a little bit different. We're going to start at one vertex and go to another. Now, this shortest path method, this method does always work, this algorithm, without doing all the calculations from one point to another, although you actually kind of do a little bit, but we'll see how this works. Okay, so the shortest path algorithm was made by E.W. Dijkstra. And with this is and does find the shortest path. So the shortest path algorithm. Well, I guess what I'm going to try to do is just probably walk through the algorithm as I go. You can review this and read this, and then I'm just going to show it with this example here. So our objective is to go from A to F and do the shortest path. We did do this before, and you kind of figured it out. This is kind of a simple, excuse me, a simplistic graph that we're working with, and so it's not too difficult to just calculate that out. But this is the method that's used so that when we get to more difficult problems, you can write a computer program or you can go ahead and do this yourself. So the first step says label the starting vertex S and circle it. So I'm going to call this S and circle it. Then you're going to darken the edges that are the shortest length from S to any other subsequent vertex. So what happens is that we're going to go from here to here because this is a 2. Compare that to 5. Yes, the 2 is the shortest, and so I darken that edge. When I darken that edge, I go ahead and circle the vertex. And that's all in step number 1. Okay? Now, what we do is we examine all encircled vertices that are adjacent to the circle vertices in the graph. So what I'm going to be doing is I'm going to look at E, I'm going to look at D, I'm going to look at B. Those would be the 3 that I'm connected to. Now, when I do that, it says using only the circled vertices and darkened edges between the vertices circled, find the lengths of all paths from S to each vertex being examined. So in other words, I'm going to go here to get to E. I'm going to go here to get to D. And I'm going to go here to get to B. I could go here too, but what I want is the shortest path. So if I look at this, this would be a total of 4. This is a total of 5, so the shortest path would be here. Now if I look at this total starting at S and going to D, that would be a 6. 4 is less than 6, and so I'm still working on the B. This one here would be a 6 plus 2, which would be an 8. So from this, the 2 plus 4 would be the shortest path of all the vertices that are adjacent to the circle ones that I have from previous method. Okay? So this would be step 1 that I'd circled. This one would be step 2 that I circle there. Now we want to do this again, so we keep on repeating this. So I look at the vertices that are adjacent to the circle ones. I got E and I got D. Those would be the ones. So I need to find the shortest paths to that. So I know I got 4 and I got 7. Here I got 6. Oh, that's looking promising. And then here I got 8. So the 6 is the shortest one. So there I'm going to circle the D. Now if I do the remainders, this is 6 plus 2, which gives me 8. This would be 4 and 2, 2 and 4, so that's 6, and then that would be 10. So which one's the shortest of those two? Well, 8 would be the shortest. So I'm going to circle here and do that there. Now the remaining vertices are the E and D, and they are both connected to F, and so I'm going to reach a conclusion at the end of this one. So I'm going to follow this path. This would be a 2, that would be 6, and that would be 10. So I have a 10 when I go from S, C, D, F. And then here, the other way would be to go S, C, D, E. So that would be a 8, and that would be plus 3 would be 11. So this would be the shortest path, CDF. And so I complete this one, I circle this one, and I say that this would be my shortest path. 2 plus 4 would be 10. That is how you find your shortest path from one vertex to another. We'll try some more examples when we get to class, but this is the basic method that you do need to know. Thank you. That's a short one. Thanks. Bye.